All right. So let's see who are those that are online. Okay. If you're online, please say hi. Let's so we can proceed. Okay, well, you're welcome. How are you today? So let's go into Ohm's law. Good day, everyone. Welcome to today's class. We are going to look at Ohm's law. But before we go into Ohm's law, there are some things that we need to know. Okay? There are some things that surrounds Ohm's law that we need to know before we can go to Ohm's law and how it is applied. I hope that is okay. So let's look at resistance of a circuit, or what is a resistor and what is a resistance. So let's go. All right, copy what we have on the board. Let's explain. Okay, if you are done writing, you let me know. Let's just proceed. Let's explain. So proceed. Okay, so let's look at resistance. Resistance can be defined as the opposition to the flow of electric current. It is measured in ohms. Okay, now look at it. We have a resistor. The resistor or a resistor is a device that is designed to measure the amount of resistance. Okay, let me add amount of resistance in a circuit. Now, this is what? A resistor. This is the symbol of a resistor. When you see this thing as a resistor, when you see this symbol, you must know that this is what? A resistor. Okay? So when you see this symbol in a circuit, this stands for what? A resistor. Do you understand? So we have two types of resistor. We have a variable standard resistor and what? Variable resistor. So let's explain that one too. So if you are just joining us, don't forget to subscribe to this channel and turn on notifications. All right, so we can explain. Now we have types of resistors. We have we have standard resistor. It's a type of resistor that have a fixed resistance value. Okay, it's a type of resistor that have a fixed resistance value. Example, we have 2 ohm, 5 ohm, 10 ohm, and etc. Right? So they are all classified under standard resistor. So you can see a resistor that has just 2 ohm, or the one that have just 5 ohm, right? So this is classified under what? Standard resistor. Do you understand? So let's go to variable resistor. This is a type of resistor whose resistance can be what? Varied. So example is rheostat. We have different types of resistors there. We can vary it at the same time. So that is classified under variable resistor. Hope you understand. Okay. In a way, you're welcome. Please don't forget to subscribe to this channel. So right fast so we can proceed. We have so many things to talk about.
Mom, maybe she said it.
All right, so copy what we have on the board. So let's proceed. At Osakwe, you're welcome. All right, we have electric circuit. An electric circuit is the part or the complete part provided for the flow of electric current. Okay, now for current to flow, the part must be completed. There are some components that make up electric circuit, so we call it electrical components of a circuit. So they are, this is what, cell, this is a cell, this is a DC source. So when you see this symbol in a circuit, it means a cell, and a cell means battery. So you may asking what is a cell. Okay, now this is a DC source, this is a resistor, this is a symbol for a resistor. Okay, this is a switch, a symbol for switch. If this switch is closed, current will flow in a circuit, but if this switch is open, current will not flow. Now this is a capacitor, a capacitor. So remember that a cell does not, okay, the metal plate does not have equal lines, but for capacitor, the metal plate, they have equal lines. Now this is an ammeter denoted by symbol A. This is a voltmeter, this is earthing. So all these are what, components of a circuit. All right. Okay, are we done writing? Please, if you are done, just indicate. Let's proceed. All right, Obinkem, you are done. Oloze, you are done. Okay, so let's proceed. Jennifer, you're welcome. If you are just joining, don't forget to subscribe to this channel, okay? Okay, the diagram we have on the board is the electric circuit. Okay. Now you have this circuit, okay? Now this is a voltmeter, this is a resistor, this is an ammeter, this is a cell, and this connecting wires. This is a rheostat, okay? Now all these are components of a circuit. Voltmeter must be connected in parallel to the resistor because resistor is the load, okay? It will help to reduce or to manage the amount of resistance that is allowed to flow in this circuit. Now parallel is always connected in what? In series, so that the current that's flowing through it can be detected accurately. Do you understand? Now this is a cell or what? Battery. This is a key. Once this key is closed, current will not flow. But once this key is closed, current will flow. But once this key is open, current will not flow. This is a rheostat that measures the amount of resistance. Now, apart from all these things that I've mentioned, every other thing you are seeing is said to be the connecting what? Wires. Do you understand? Every other thing you are seeing is they are all connecting wire. That is the wire we use to connect all these things together to form a circuit. All right. Okay, so let's proceed. All right, so let's look at the arrangement of resistors on the board. We have series and parallel connection. Now, if we have three resistors connected in series, we are simply going to do, look at them, resistors R1, R2, R3 connected in series. Straight line means series, okay? We are going to say the total or effective resistors is said to be what? R1 plus R2 plus R3, okay? But if they are connected in parallel, which is this way, the effective resistance becomes 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Put it down, please. All right, I hope that is clear. Are we done? Nengi, you're welcome. Okay, let's look at the question on the board. Please don't forget to subscribe to this channel, okay? And like this video. You can even share it for others to see. Okay, let's solve. This is question 1 and this is question 2. But what are we looking for from both of them? We are looking for the effective or the total resistance. So how do we get the total resistance? Now, this one is resistors connected in series. Remember the formula. When they are in series, you're just going to add them as if you're adding numbers, okay? Now, the effective resistance for this is equals to what? R1 plus R2 plus R3, because they are connected in what? In series. So we are going to say R total is equals to 4 plus 5 plus 10. right? By the time you add them together, it's going to give us what? 19 ohms. Do we understand? This is just for series connection. Now coming to this one, this is what? Parallel connection. How do we solve it? Remember, the formula is what? 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Do we understand? Okay, so what do we do next? We now say that this is what? 1 over R total is equals to, let's go, we have 1 over 2 plus 1 over 3 plus 1 over 4. So what will be the LCM? So what is the LCM? What do we have? The LCM is going to give us what? 12. 12 can go. So we say this is what? 12. So let's go. 2 into 12 is going to give us 6. 6 times 1 is what? 6 plus 3 into 12 is going to give us 4. 4 times 1 is what? 4 plus 4 into 12 is going to give us 3. 3 times 1 we have what? 3. Okay? So that gives rise that 1 over R total is equals to 13 over what? 12. But the question says you're looking for effective or total resistance and not inverse of the total resistance. So if you have question like this, what do we do? This is not your final answer because what you're looking for is R total. So we say cross multiply. R total is equals to 12 over what? 13. You just have to carry this denominator up and take the numerator down. So my R total is equals to, you can use your calculator to find out. So we say 12 divided by 13. My answer is 0.92. So this is 0.92 ohms. Do you understand what I just did? All right, put it down, please. Please, do we understand? All right, are we clear? Let's move to the next example. All right, so let's move to higher and more advanced examples. All right, look at the question on the board. So let's see how we can solve it. The question says we should calculate the effective resistance from the diagram above. How can we calculate the effective resistance? So let's solve. Now look up. If we want to calculate the effective resistance from this diagram here, look at this. This is 2 ohm. This is 6 ohm. Sorry, this is 3 ohm, 4 ohm, and 5 ohm. We have 6 ohm. But what that will interest you, or what you should be interested in finding now, that is the first thing you must do, is look at these 3 resistors. They are connected in parallel. Okay, so you're supposed to get the effective resistance for these 3 resistors connected in parallel. So when we are done with that, whatever answer you have will not be in series with these 2. Do you understand? So the first thing you're going to do is to solve for resistors in parallel. That is the first step. Now we have how many? We have 3. So let's go. 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay? So we have this is 1 over R total is equals to 1 over 3 plus 1 over 4 plus 1 over 5. Okay? So let's get the LCM. What do we mean by LCM? Okay, class, what's my LCM? We have 3 times 4 is 12. 12 times 5 is 60. So we can use that as our LCM. So this is what? 60, right? All right. So 3 into 6 is going to give us what? 20, right? 20 times 1 is 20 plus 4 into 6 is going to give us 15. 15 times 1 is 15 plus 5 into 60 is going to give us 12. 12 times 1 is 12. So let's add. What do we have? We have 20 plus 15 is 35. 35 plus 12 is 47. So this is 47 over what? 60, right? But remember, what you're looking for is R total, or total resistance, or effective resistance. So I'm going to say RT is equals to 60 over 47, right? Okay, so I'm going to use our calculator to do that. That is 60 divided by 47 is going to give me 1.28. 1.28 ohms. Now, what I just calculated is just these resistors in parallel. So for me to get the effective resistance of this circuit, I'm going to say, draw the diagram by saying this is okay. Now this one is what? 2 ohm. Then the 3 of them, I've gotten them to be 1.28. So this is 1.28 ohm. Then this is what? 6 ohm. Do you understand? So by the time you get the effect, you are going to say that RT is equals to R1 plus R2 plus R3. So simply by saying that R total is equals to 2 plus 1.28 plus 6, right? So by the time you add them, it's going to give you 9.28 ohms. Do you understand? So the answer to this question is 9.28 ohms. All right. Please, do we understand what we did at Kewe, Nengi, Aloze, okay? Do we understand? In our, what do we understand? At Osakwe, do we understand? All right. Inawo understood, okay? Osakwe done, okay. So I want to give you what they're going to try for me. Just one example. Let me give you what they're going to try for me, okay? Let me see your what you understand by that. Just one example. Try one for me, similar to what we just did. Okay, at Kewenengi, you have the question on the board. Please, can you attempt it and send in your answers? At Kewenengi, Inawo, Osakwe. Please, can we attempt the question and send in your answer? Let me see if you understand. Please, can we send in our answers? I'm waiting. Okay, then you send in your answers, right? Look at the question and solve it, send in your answers. In a way, you're confused. How come I'm seeing your message now and I just cleaned the board? Since network was bad. Okay, you're confused at the question I gave you. Okay, so what's the confusion there? Okay, now let me explain. Look at this question. Hope you are seeing the board very well. Hope it's very clear. Okay, now look at the question now. This is point A. This is point A. Okay, now we have this. This is a resistor that is on its own, 4 ohms. This is 2 ohms. This is 1 ohm. Okay, these two are connected in parallel. Now look at these three. This is 3 ohm, 5 ohm, and 5 ohm. These three are also connected in parallel. Now the question is calculate the effective resistance. Okay, so how do you calculate? I'll just give you a clue to see if you can attempt it. These two are in parallel. You're going to solve them together and keep it one side. Now these three too, you're going to solve them together and keep it one side. When you are done, it will not be in series with 1, 2, 3. So we'll now have 3 resistors. So you'll now add them together as though they are series. That becomes your final answer. I don't know if you understand what I explain. I don't want to go into details so that as if I'm telling you what to do. So I just explain. The way I solve for resistors in parallel, solve for these two separately, solve for these three separately. So when you are done, it will not be in a series, that is in a straight line. Okay, so try it that way. Okay, well, you have 7.36 ohms. Okay, in our, just solve it separately the way I just explained. You're going to get the correct answer. All right, so who else is solving? Who else has solved the question? We only have one answer here, so who else is solving? Inawo, can you solve? Or what do we have? Nengi, are you there? Okay, Inawe, what do we have? Nengi, what do we have? At Asakwe, what do we have? At Obinken, what do we have? Okay, I'm still solving. All right, so I'm waiting. All right, we are still solving. Okay, Nengi, are still solving. Okay, so I'm waiting. You know, we got 5.96 ohms. Okay. So Nengi, what do you have? At Osakwe, what do you have? Okay, I'm not too sure. No problem. We're going to practice it now to see whether you are correct or not. At Osakwe, 5.9 ohms. Okay. Nengi, 7.36 ohms. Okay. All right, so let me see. Let me solve it so that we can proceed. Since we don't have much people today, so we don't need to waste much time. So let's solve. Okay, so we have these two, they are connected in parallel. These three are connected in parallel. So let's solve them together first. We have 1 over r total is equals, I'm going to solve for this one first, equals to 1 over 2 plus 1 over 1, right? So the LCM is what? The LCM is 2. 2 into itself is 1. 1 times 1 is 1 plus 1 into 2 is 2. 2 times 1 is what? 2. That is 3 over what? 2. But what we are looking for R total is going to be 2 over 3, right? Now by the time we divide it, it's a 2 divided by 3. It's going to give me 0.67 ohms, right? This one is just for this. You know, and Kevin, hope you are together. This is just for this. So let's solve for these three that are in parallel too. So 1 over R total is equals to 1 over 3 plus 1 over 5 plus 1 over 5, right? Okay. So my LCM is going to give me what? 15. 3 into 15 is going to give me 5. 5 times 1 is 5 plus, this is going to give me 3. 3 times 1 is 3 plus the same thing, right? So I'm going to have 11 over what? 15. So this is 11 over 15, right? So, but the R total, that is, RT becomes 15 over what? 11. So by the time we divide, it's going to give me 1.36 ohms, right? Now that is for this particular one. So the diagram will change to be this way. I see it now. So this is my 4 ohm. Now when I added these two together and I got 0.67 ohms. Okay. Then I added this one together. I got what? I got 1.36 ohms. Do you understand? So let's solve it now in series. So this is what? R total is equals to R1 plus R2 plus R3. Now, R total is equals to 4 plus 0.67 plus 1.36. So let's work it out. We have 4 plus 0.67 plus 1.36. So my R total is equals to 6.03 ohms. Do you understand? So this is my what? My effective resistance. So who got the answer? So who got the answer correct? Wow, none of my girls got the answer. At Kewe, at Nengi, at Osakwe, at Inawo. Have you seen your mistake? Have you seen your mistake? All right. You have question? Do we understand now? Okay, you have seen your mistake. Okay. Okay, Nengi, okay. Okay. Yes, let me give you another one to try. Let me give you another one to try. All right, so you can try this one. Let's see what we have. Okay, you can drop in your answers. All right, you can send in your answers if you are done. Okay, now we have 7.53 ohms. All right. At Kewe, what do you have? At Kewe, what do we have? At Nengi, what do we have? Okiri, you're welcome. At Nengi, what do you have? At Kewe, you're still solving. 7.5 ohms. Okay. Nengi still solving. Okay, I'm waiting. Let's give you some time. Okay, at Nengi, you have 7.50 ohms. At Obinke, we have 7.50 ohms. Okay, Nengi, you have 7.53 ohms. So let's solve and see who got the correct answer. Let's solve together. Now, these two are in parallel. We are going to say that this is what? 1 over RT is equals to 1 over 2 plus 1 over 3, right? 1 over RT is equal to LCM is what? 6. 2 into 6 is going to give us what? 3. 3 times 1 is 3 plus 3 into 6 is going to give me 2. 2 times 1 is 2, which is 5 over what? 6. So if let's proceed. How's the network? Okay, so Let's leave this one and solve this other one. Say 1 over r total is equals to 1 over 2 plus 1 over 4, right? 1 over r total, what's the LCM? My LCM is going to be 4, so this is 4. 2 into plus 4 into itself is 1. 1 times 1 is what? 1. So this is 3 over what? 4, right? Now my r total is going to be 4 over 3, of which when we divide it, it's going to give me 1.33 ohms, right? Now, we have gotten this to be what? 1.33. So let's bring them together. The circuit will now be this way. So this is what? 1 point, and this is 5, and this is 1.33. Okay? And this is ohms, ohms, ohms. So they are now in series. The effective resistance becomes R1 plus R2 plus R3. Okay? Now that will be 1.2 plus 5 plus 1.33. 7.53 ohms. That is my effective or total resistance. Hope that is clear. So we all got the answer. We are close to we are correct. It's just like that particular student that wrote 7.50. Okay, but if you approximate, you are still what? Correct. All right. All right, so let me give you assignment for today's class. We're going to continue tomorrow, right? Let me give you assignment. All right, so this is your assignment for today. So you're going to solve it and drop your answer in the comment section. Let me see who gets the correct answer. So thank you for staying and sticking to the end of this class. We're going to see you next time in the next one. Bye for now. Ibina boy, you're just joining. We're going to meet tomorrow same time by 1. It's just 1 hour class. I don't want it to stay long. So it's just 1 hour class, okay? We're meeting again tomorrow by 1. Oh, okay, 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 okay. Inawo, okay. All right, so take down the question so we can end the class. Okay, I know say you are done, okay? All right. So no problem, we can end the class. Okay, well, we done. So you can send your answer in the comment section when you are done. Okay, I stop, we're done. Okay. No, we are not sending it now. Send it in the comment section of this my channel where you are done. Okay? So I'm not sending it now, okay? All right. So I'll see you people tomorrow, same time by 1 p.m. Bye for now.